Here's the next mission for the shed. This is a hub off a final drive on a Dingo, just like a small bobcat that you stand on the back of and ride around. There's heaps of different attachments for it. This is the wheel end, so a shaft goes in here, and on this flange on the bottom is where the wheel bolts on. So the whole axle is actually the motor shaft, the hydraulic motor shaft. Pretty substantial looking shaft. This goes in here, key round like that. There's big needle roller bearings in here, and spline up inside here. It's driven. So what's happened with this one, as you can see, the key's broken out. I've filed this, it seems a bit hard, and the way that internal spline looks, this nearly looks like a powder metallurgy part, potentially, that's been sintered and then ground. These are all ground surfaces, another one here, another one here, 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 here. Of course the taper, and then the thread's been machined. I think maybe what's happened, I'm not 100% sure. So you know that in this here, the taper is a driving taper. So if this was a nice matching fit taper, then there should be enough friction on that taper to never ever slip in here. So at some stage, either the nut's been too loose, or the key's been an interference fit and bottomed out and not actually let this thing seat properly maybe. And it's allowed this to walk in there, and then the key's sheared. If I zoom in there, you'll be able to see the carnage inside that hole. You can see it's minced it pretty good. So this is a 5/16 Woodruff key. I'll zoom back. Oopsie. 5/16 Woodruff key. You can see it fits the groove widthways really nicely. But the issue, I think, is that it was the wrong one. So see, it's never bottomed out. It doesn't sit in the woodruff. So you can get different diameters of these, different arc. Potentially, you know, this was sitting, the previous key that was in there, I'd heard from the owner, had been ground down to fit the slot. Maybe that was still a little bit too high, I don't know, but either way, from forward, backward, forward, backward, forward, backward, which this thing drives the axle of like the little front end loader, like I was saying, you know, it's eventually just broken the side out and smashed out of it pretty substantially. So this is a Parker part. The owner has purchased a brand new one, Smeko. That's the 5/16 key. The key didn't come with it, but again you can see it's the wrong one. It's the right width, however the wrong diameter, that wrong arc. So I have to get the right key so that seats down properly, and then be very careful of the height to make sure it fits the keyway properly. So the repair on this, what they've asked me to do is to build up this hole and then remachine it to this taper and then recut the keyway. So the way you do that, you'll see this stub has got a center in it, and it's all nice and parallel. It's been nicely ground, and if you look carefully just here, there's a nice little taper, a little bevel they've put on, a little chamfer all the way in there. So what I'll do is the 4-jaw's in the lathe at the moment, which I'll leave in there. What I'll do is I'll put a bit of steel in there, and I'll machine a point on that bit of steel, and that way that piece of steel is true to the axis of the lathe because it's been machined in the lathe. That will then go in here into that point, and then in my tailstock, which I know is set on center, I'll put in a pipe center, and the pipe center, as you know, is just a big live center. It'll sit and pick up that radius there, and this should sit fairly true. Then confirm that, I'll dial this surface and just make sure it's parallel. And then what I'll do is I'll offset the compound slide on the lathe with the dial on the compound slide, and I will trace this taper. Once I know that taper, I'll then put this hub in the forge jaw and I'll machine out this bad material. Probably take the key away, or I don't know yet. I might just try and grind that out, don't know. I'll then fill this up with weld and then remachine the bore true to that taper. After that, we'll be cutting the keyway. Alright, let's get into it. .01. That's pretty good. That's 0.01 of a millimeter, by the way. And that's the same. So that's pretty good. So that's on 0. So I've moved about 1/10 of one of those divisions, which is 0.001. We'll probably just tap it around. So that got, pull a needle. So the gap got bigger. So I need to turn it this way, try a little bit. And we'll clamp it again. And this time I'll also clamp the front one. Okay. We'll go back the other way. Looks like we got it bang on there. It's not moving off the 0. It's still not bang on the 0. So that's pretty good. And now what you should do is go to the other side and repeat that, just in case. So we've got this hole at the top now. Alright, let's go this way. Still on the 0. Yeah, that's gonna be pretty close for me. Okay, so that's how you do the setup. So that's how we find out what the taper is. And now that the compound slide is set, any cut that we take with the compound slide only will trace that exact taper. The plan is now to set the hub up and skim out all that rough material that was inside it. When we take a cut with this compound slide, it will follow that exact taper and it'll match that one. So the plan now is to, this has got a certain depth that it can only pick up a certain amount of thread and a certain distance from this next feature here. So if we were to machine that bore out, that whole hub would translate up the shaft too much. So what we've got to do is skim material out of that bore, weld it up on fresh material, and then bore it back out to size, make sure the major diameter of that taper finishes up the same as the other one. And that's it. Alright, so all of this here was just for setup. I'm just going to explain why it's done like this, that you machine a hole out and then weld it back. Why not just weld it up and then machine it? Well, the reason is if you were to look at the hole that we've got here, we've got a tapered hole like this, and it's damaged. You know, the hole's the surface like this all the way through. So we no longer have this nice machined taper anymore. This is the actual surface we got. So if you were to come along then and place a weld over this, you'd follow that shape. And what you'd finish up with is any contaminants, whenever that shaft broke or the key broke or whatever happened, you quite often find contaminants get embedded into the surface of that damaged surface. You get all sorts of fretted material and whatever, who knows what's ever in there. When you weld over that, you finish up with, depending on the carbon content of the steel and the weld material you're using, you finish up with hard spots all the way through, which is sort of mixed into that weld pool as it goes. And when you come across later and try and machine this out with your machine to re-establish that surface, you come along and quite often run into these hard spots. And what will happen is, if you were to look at that surface a bit closer, let's just draw it in here, as you're machining along the nice soft material or the homogeneous, the nice uniform material, then you hit a hard spot, your tool will deflect and you'll finish up with a little bump. Wherever you hit a hard spot, or potentially even a soft spot, tool deflection, you'll get all these bumps and craters and you won't actually get a nice smooth straight path. So that's why you machine, let's draw it on this side, you get all of this surface that's damaged and you just machine all that out, get rid of it, make the hole bigger. So then you've got a nice clean surface of parent metal and you start laying your weld beads on top of that. So any mixing that happens in the penetration zone of the weld is only between two different metals rather than three or four, whatever contaminants were there being removed, and you'll build all that up and keep laying beads on top and make it proud. The key is to put enough weld in there to get over the top of where you need to be, so that when you when you machine that surface, you're only machining the weld metal. And that pretty much sums up why you do it like that. Now it's raining outside again, but all I've done here now is got the hub. I've sandblasted where the jaws go, get a good grip. Sandblast the face as well, just to clean it up a little bit. We've got two dials running here, just a normal dial running on the face, and then a finger dial running inside that register there, and just dialed it in roughly just to so I can skim out the guts of that hole. I don't know if it's had a shot yet of the depth. As you can see there, it's pretty ordinary. So now I'll put a tool in the tool post. The compound side's still set, so we'll skim all that crappy material out. You can see now we've cut the hole. Move this over a bit of a look. Cut all the muck out of the way. Clean the hole up. The plan with the keyway is we'll fill this with weld and I'll cut the new keyway on the other side in this fresh material here. The reason this is located, actually, this is in line with these holes here. That's so that once the shaft's in the hole, the key orientates the shaft in the hole, and then this hole here is a through hole, comes right through the other side. That's to allow you to be able to get the split pin in through the end of the shaft. So you can see the shaft, the key lines up with the split pin hole. It's got a castellator nut, so this goes inside, and then inside here, once it's mounted, you'll see it lines up with that hole at the top. So this key obviously needs to be in the right place. We won't put it here again because this is all damaged and yucky, and I'll fill that with weld. I'll probably get a little burger on and clear all that up, or maybe file the guts out of it and make sure it's nice and clean. And we'll lay a couple of beads in there, and then we'll build this up over the top of that. But like I said, I'll mark this, and we'll make sure the new key is in the new keyway is in fresh material, not in this junk here. That's it. We're back from the welding bench. I took the MIG, filled in the keyway, and then built up the bore all the way through to the back. Now you can see now I've got the job dialed in the forejaw back in the lathe. I dialed it on this face and this register, just like before. You can see that, you know, I've closed that hole up quite a bit, which now won't allow the larger boring bar to fit in the hole. So I've got a selection here of smaller bars, and you can even see, you know, if I was to take a path into here, it still won't make it all the way to the back. So that's not a good candidate. I've got a smaller bar here. Same thing if I took a path in, it still obstructs at the back, doesn't make it right through. So the best thing to do is to drill it. So here I have a 23.5mm U-drill, bought off eBay a long time ago, and I bought inserts for it, matched it up. It had no inserts when I bought it, but I figured out off the manufacturer's name that's on here somewhere. There, it's an ISCAR. There's an ER32 collet holder to Morse taper 3. It's in there. It's the right collet for the U-drill. Always make sure that this flat here, that the collet always sits up on those two flats. I'll put the collet like that. I always make sure that collet's fully home. Here's a really good example of what I was talking about before. So I've just taken the face of that weld down, and you can see the hard spots in there. So that is weld metal, and that's the parent metal of the job. And something's happened where it's made that hard as hell, and the finish on it has come up different. Look at that. So you can see the heat affected zones of the welds, and then whatever's happened in that area has made it hard. So, you know, this bore I'll machine probably up to where my fingernail is, and it'll be all in this material here. It won't, none of it should be in the, you know, in this mixed section. But I mean, that's probably just displays a good example of what I was talking about before. If you were trying to machine a really accurate surface in there, then it's going to have all ups and downs and ridges as this tool. You'll probably find if I was to measure this with something really accurate, which I don't have, you'll probably find that those spots there are actually higher because they're harder. You just push the tool away from it. So you really don't want that in a bore, especially on a taper, because you want that shaft in full contact along that taper. So anyway, there you go. So next thing, so the U-drill's been in here and made that hole. I've just faced this, just roughed that out, got rid of all the high welds and brought it back and blended into this corner here. And now I'll start machining the taper. That's about it for the machining in there. Just test fit it again and blued it, and you can see down through the hole, you can see the end of the hole in the shaft that the split pin goes through. You'll also see here I put a Nico pen mark to show where the old key was. So when the new key goes in, we'll put it around on the other side, line it up with the other hole. So basically that hole there, so we'll put the new key in this side lined up with that hole again, so you can get the split pin in the hole of the shaft. Now I've tapped that in there with a soft hammer, and I'm going to pop it out now and just bash it on the back of the shoulder, pop that taper and just have a look at the contact. It's nice and sturdy. I ran a dial indicator on this before, and way out here there was 0.05, which is 2 thou. So considering a big needle roller bearing runs here, and whatever else runs there, probably another bearing, and this has taken the whole weight of the machine because this is the wheel bolts onto here. There's a chain driving this. I had to make sure I left enough clearance in there, because the more you machine, the larger you machine the hole, make the hole bigger, the more up that taper it's going to travel, and then that'll change the alignment of the chain where the chain runs in relation to the machine. This is fixed obviously, and then you know it would shift that sprocket. When I originally looked at this, I've gone and faced this just to clean it up, just to blend that weld in, but before that, or you've probably seen on the earlier shots in the video, you actually see right out probably to near my fingernail there was like a discoloration, like there was a big washer or something maybe there. There's a taper here on the shaft, which I wouldn't imagine a washer would sit up against. I would have thought that would be like a square shoulder or something. So there is 3 millimeters of parallel shaft just there before the taper starts. So I've gone about 4 millimeters, but from the of that parallel section sticking out. I don't want to take any more off, because once you take it off, big job to put it back on again. You've got to basically do the whole job again. So I think I'll stop there. There you go, out of the machine. A bit of a wipe with a dirty rag. See the bores come nice finish. You see the heat affected zone of that weld. That was the keyway side. The new key will get bored in this side into the fresh material in line with this hole. The previous key was there, as you can see. It's amazing how different the tool skips across it, but the bore come nice. A couple of little porosity holes, like you can see one there, where either the shielding gas from the MIG didn't get in there properly or whatever happened, but you can see the bore all smicko. Finish come up nice and smooth, and the shaft fits. I'll flip this around now in the four-jaw. We're grabbing it on the inside of that register that we dialed up off on before. So I flip the jaws around and we're pulling outwards. Stuck the bore and bar out just enough to reach the bottom of the hole before it hits the tool post. And what we're going to do is go inside now. I've dialed this face and also the run out. I'd give it a little touch in there as well with a little finger dial just to make sure that everything was nice and straight. What we're going to do now that this is set up in the lathe and it's running true, we go in there and face. You can see where the weld is proud, because I welded it all from the other side, stuck the wire right out. You can see a couple of dags here where the wires touch the side. But basically, I was flat out getting the torch right in from the other side, so I had to have a lot of wire sticking out. So I tend to let the wire run out so that the area is flooded with gas, with shielding gas, and then bring the wire down onto the job so that you've got a good shield, and then whatever wire pokes through, well, it doesn't really matter, you knock that off later. So what we're going to do now is just pass my finger there. I can't reach right inside, but that surface there, we've got to get rid of that proud surface because the shaft comes through this hole, and then there's a big washer that goes against that face and pulls the shaft into that taper. Alright, so we'll do that. I'll probably do that off camera because it's going to be a mongrel trying to set this up to try and get a camera shot in there while we're doing it. So I'll show you once it's finished. And here's what it looks like. So I've still got to knock them dags off there from the welder. You can see a couple of heat affected areas there from the weld that are hard. I've got to clean it up yet. I've run a deburring tool in there already just to, it's like your Noga deburring tool. Run that around inside the hole, clean the edge up, tried to chamfer it from the inside as best as I could with the tool. But that's pretty much it for that job. So I'll knock these dags out just in here, that one and the other one. And that's it. Ready for the keyway to go in. This is what we're up to with making the new castellated nut. You can see that nut that I had before. I faced it and bored the guts of it out to the minor diameter of the new thread, which is this one, inch by 20 threads per inch. You can see even though it's to size now, there's still some of the old existing thread in there. It's trying to focus on the wrong spot. It's not much, but since I've come this far, I'm going to keep going and punch the new thread through it and just see what it comes out looking like. You will still see this spiral, I'd say, on the tops of these threads, but once that thread's in, you may not even pick it up. So the distance between each one of these threads is quite coarse, so you might find that as a comparison there might be 2.5, nearly 3 of these threads inside the top of one of those. It's not ideal, but like I said, I've already come this far and that nut is now good for nothing, so I may as well, it takes nothing to punch the thread through it. So I'll set the machine up now to turn that and we'll see what it comes out like. Just as a little bit more info, this thread here is actually a standard thread. So you can get a thread called UNC, which is Unified Coarse. There's UNF, which is the fine version, and then there's a UNEF, which is Unified Extra Fine, and that's what this is. So this is a standard thread out of a UNEF thread table. So if you look that up, you'll see 1 inch by 20 threads per inch, and that's what this is. Okay. So I've taken this thread to size now. All I'm doing is just a couple of spring passes just to give you the idea. Because it's a through hole, you can go pretty fast. So the spindle's spinning at 1,255 revs a minute. This is the final size diameter. So all I do is take the cut. This lathe's got a foot brake so I can stop the spindle, and then I back off a clearance amount, back, reset the cut, take it, and this is what it looks like. Back a safe distance, and stop again, and back to the spring pass, and stop, and back to the spring pass depth, final size, stop, screw it back in a safe distance, backwards, and over and over and over. So that's how I've cut. Gives you a bit of an idea, that's how I've cut the thread the whole way down. So sometimes what you would do is set the tool up at an angle, just like what you would on an external thread. You'd be following the, you'd be following the V of the thread down like that, but in this case I'm just plunging straight in and taking lots and lots of light cuts, but in the bore of that hole, obviously. And that's about it. I'll just unclip the camera and you can have a look inside the thread. Whoopsie. All nice and smicky dicky all the way through. And while we're going, we'll just screw this out of the way. And try the bolt. Well, the start's not the best. It's a nice fit, that. Yeah, nice. That is nice and firm, that. It's good. Nice fit. And that's it. Now what I've got to do is, I may try and just mark this in the lathe now while it's true to this face. Mark it and give me some guides so I can cut this nut in half. I'd like to be able to get 2 nuts out of it. But I haven't actually measured the nut properly yet. It's going to go that way obviously because I've faced this true to the axis. It doesn't really look like I'm going to get 2 out of it. I might. They might be a bit scungy though. It'd be nice to get 2. It'd have to be extremely thin cut, like a 1mm cut-off disc or a nice thin hacksaw blade, and just cut it all by hand and then face off any wigglies that I make in error with the hacksaw. So we'll see. I'll have to have a think about that. I might just make one good one and see what's left over.